Hello, and welcome to Identifying Factors by Dividing. This is Chapter 3, Lesson 4 from the Nelson Math Focus textbook. I'm Mr. Burko, and you're listening to my Mathcast.
Hi, Mr. Burko.
Hello, Mrs. Burko. Mrs. Burko is joining me today, but I think she's just going to say hi and then disappear into the background. All right. In our lesson today, our goal is to identify factors by dividing composite numbers by primes. Now, there's some terms here that you need to understand before we proceed. If you're not really sure about factors and composite numbers and primes, you're going to need to look at lessons 1, 2, and 3 again, where I introduce those terms. I'm going to go through them really quickly right now, though. A factor is a number that you divide another number by. A composite number is a number that can be divided by another number other than 1 and itself. And a prime number is a number that can only be divided by 1 and itself. Alright, in our game today, we have Leah and Daniel. And this is a game that's found on page 82. And the game is to choose a card that has a number on it in between 40 and 50. And the number that Leah chooses is 45. Now the goal of the game is to get the most prime numbers out of this number. So what she's going to do is she's going to take 45 and divide it by a prime number, and then the number that she results in after dividing it by 45, she's going to divide again by another prime number, and so on until she's exhausted all of her composite numbers and she only has primes. So here is 45. She's going to divide it by 5, which is a prime number, and of course she gets 9. Now, 9 is a composite number, so she's going to divide 9 by 3, which gives her 3 again. Leah ended up with a 5, a 3, and a 3, but because there's only 2 unique prime numbers, she scores 2 points for this game card. Daniel chooses 40, and Daniel decides to do a tree, so it's a slightly different approach than Leah did. Daniel divides 40 by 2, which is a prime number, and he gets 20, because 2 times 20 equals 40. He divides 20 by 5, which also is a prime number, and he gets 4, and 5 times 4 equals 20, just to check. And 4 divided by 2 equals 2, or 2 times 2 equals 4. So Daniel also scores 2 points for his 2 and his 5, but these 2's are repeats, so they don't count. So one thing that is really important to take note of in this particular lesson is that 1 is not a prime number. You might remember in our last lesson when we did our hundreds table and we circled all the prime numbers, we didn't circle 1. We just left it blank because 1 doesn't qualify as a prime number or a composite number. It can't be divided by 1 and itself. You can't divide a 1. So basically, it's just on its own. It's your turn. I would like you to take each of these 6 cards, and I'd like you to divide them down to their prime numbers, just like we did in Leah and Daniel's example, although I'll let you choose whether you like to use Leah's example or Daniel's way of doing things. So you can either do a factor tree or you can do division. We've got 42, 44, 46, 48, 49, and 50, and I want you to find out which one scores the most points. If you have a friend over, or if you have a brother or sister that's old enough to play this game with you, you're welcome to go ahead and play it with them. Or maybe you want to call on your parent and play the game with them. It's up to you. Or you can just do it by yourself, but it's good practice. And if you do this, then tomorrow's lesson will come a lot easier to you. Well, thank you for joining me. I hope you had fun factoring those numbers down. And we'll do more of that in class tomorrow.